So you want to solve thermodynamics problems?
Yes, sir.
Okay. Try this one.
Okay.
I think we have done this, no? Done this. Background
Yes,
noise.
sir.
Yeah, background noise is there. We have done this one. Remove the background noise. Okay, this is a trivial question. Question number 9.
Q equal to du plus
1988.
A and C. Okay, all of this.
No, there is nothing called conservation of work and conservation of energy. You have conservation of energy, conservation of momentum, conservation of mass. Other than there is nothing else. Okay, so he's asking conservation of what? So it's energy. It's actually conservation of energy applied to your thermal system.
Okay.
Okay, I think we have done these things. What about question number 8? Oh, this is the trivia 1993. This is based on which law?
B. First law of thermodynamics.
Yeah. 1993, that's it's simple. Yeah. Right. So we'll move to this one then. 2020. Question number 10. Oh, this also trivial. The theoretical question.
Isobaric.
Question number 11.
Question number 11.
This is also a trivial sort of theoretical question. It's suddenly open, right? So whenever things happen suddenly, so will it be isothermal or adiabatic? Suppose I give only these two possibilities. Okay, when things are happening suddenly, which one is possible?
So they have given like thermally uninsulated means adiabatic also.
Yeah, see, for an isothermal process, we should have to do it slowly because for the temperature to remain constant, you have to give some time for it to radiate the heat out to maintain the temperature. For example, if I take a gas in a cylinder, simple problem, and I try to compress it, when I try to compress it, work is done on the gas, so temperature will go up. Okay, so but if the cylinder, the gas in which it's kept, if the cylinder is perfectly conducting, and if it push the piston slowly, then the gas has got the time to radiate the heat. So its chance of it remaining isothermal is there. So in general, isothermal process is a slow process. In the sense like if you do the process slowly, then it is possible for it to become isothermal because you're giving it time to radiate out heat so that temperature can be maintained. So when things happen suddenly, there is not much time for the heat exchange to happen. Adiabatic means heat exchange is zero. Okay, so when things happen suddenly, it's most probably adiabatic. Okay, so I think you are doing the same design according to first law of thermodynamics, which are one of these. Okay, this is question number 11. You read the answer.
So
has it said it's insulated? No. Okay, thermally insulated. Okay, fine. Okay, so there is one more reason it was starting. So thermal insulated, there is no heat exchange. So that is basically the definition of adiabatic. Right? Adiabatic means there is no heat exchange. Oh, this is also trivial.
which of the following processes heat is neither observed nor by a system? That is the adiabatic, sir. Heat remains constant.
This one. So B versus P, the process is shown, the ratio of working the gas to the water. So A to B, okay, A and B are 2 points. Okay, so these are the 2 points A and B. Just a minute.
So where is that A and B, sir? They didn't mark it.
They are not marked. So A you have to take as this point and B as this point, doesn't matter. Okay, basically.
P del V. Then mark anything. Shit.
So first law. Okay, so volume versus temperature is given. And, so find the ratio between this and this. That is PU. It's a monatomic gas. dV is how much? This is CVDT, right?
5. I think option C, sir.
Okay.
Work done is equal to P del V.
Yeah. So
N del T M by 2 N del T U equals to del T equals to F by 2 plus 1 N del T down by del T equals to 1 by 2 plus 1.
okay, how did you do it?
Del U equal to F by 2 N R del Q. That formula, sir, del Q equal to del U plus del W, so you will get it at F by 2 plus 1. They're simply asking the ratio, no, sir.
Yeah, you have to find the ratio of dQ
So
by.
you'll get it as 1 by F by 2 plus 1.
All right. And what is F for monatomic gas?
Only translational degree of freedom.
Okay. Oh, yeah. So P delta V is okay. This one, during process, beginning of the current diagram. That's the big question. Write myself to the PV diagram. Okay. The question looks good, but simple question. So this is PV diagram. No, so process 4 is isobaric, and process 1 is isochoric. Okay. So discipline 1 and 2 and 3.
Process 2 is adiabatic, sir.
Process 2 is adiabatic. Yes. Okay. So process 2 is adiabatic. Okay. Process 1 is isochoric. Process 3 is isothermic. Yeah. So which option is it? P2, P2, C, P2, C, and then Q2, A. Is it right?
Yes, sir. Because gases compress. Isothermally, the same gases compress separately through an adiabatic process into the volume. The Q is something. Then you set the W. Work done in isothermal process is
Okay,
maximum.
this is actually negative, right? You're compressing.
Yes, sir.
So if you take minus P, which is positive quantity, is PQ minus G, and this is heat added to the system. So here the temperature is going up if it is adiabatic. So this is the positive quantity. Okay, so suppose if it is adiabatic, then temperature is going to go up. This is positive. Adiabatic means so this is 0. So this is positive. Isothermal means this is 0. Okay, and heat can go out. So heat can something that is also positive. So what will happen to the pressure? Okay, one more thing is if you look at the PV diagram, it's like this, no? This is adiabatic.
Isothermal will require more work, sir.
Yeah, because
More
area, under
area.
the, yeah, the area under the curve of this isothermal is more. So which option is that? Is that right?
E, sir.
Compressing gas isothermally, okay. Compressing gas, compressing gas isothermally. Okay, okay. We are going this way, right? Volume is decreasing. So we are going this way. Okay, so the area is negative. According to this option D only. If you
Sir,
look at
in both the ways, isothermal area under isothermal graph only will be more.
okay, good. Yeah, I think I made a mistake. Okay. The top one is adiabatic.
But usually adiabatic graph slope will be steeper, no, sir. More.
Yeah, see, yeah. See, but steeper, but the starting point is the right one. See, here the adiabatic is steeper, but the starting point is the left one, right? But if you have the starting point is the right one, then the steeper curve will be above. Here, okay, the starting point is V, final point is V by 2. Okay, so initial point, both are coinciding. The conditions are same. Because the initial starting point of both the processes are same. Okay, so when you are starting from higher this point, right? Okay, then the steeper one will be above. Steeper one will climb up more, right? But if the starting point is the left one, then the steeper one will be at the bottom. Adiabatic will be the bottom. Got it?
I can't understand.
This is not the. See, you are compressing, no? So the initial point is B. Final point is B by 2. Okay. So the initial state of both adiabatic process and isothermal process are same because the starting point is same. Only by the process in which you are applying to the two initial conditions is different. The initial condition is same. So adiabatic is steeper, so it will climb up faster. Isothermal is less steep, so it will climb up slowly. But if you're starting from left, adiabatic will fall down much faster compared to isothermal. The graph of P versus V is always like this. It's inversely. Okay. So when you start from here, okay, then the adiabatic process will fall down faster compared to isothermal. But my starting point is here. Okay, the adiabatic will climb up faster, and the isothermal will be here.
Oh, okay.
Okay, the initial point is what is going to make the difference. Here we are compressing. So the initial point, the initial condition is same for both the process. So from where you are starting, adiabatic is always steeper. Okay, so if you're starting from right, adiabatic will climb up faster, and isothermal will climb up slowly. But if you start from left, adiabatic will fall down faster, and isothermal will fall down slowly. Because the relation between P and V is always inverse. Okay, that way this is a good question. D2016. Got it? Done? This is the only thing. Suppose you have this as a starting point, then adiabatic will be below. Suppose you have this as a starting point, adiabatic will be above. Because from going from here to here, it's going to go up. So adiabatic will go up faster. But from going from here to here, it's falling down. So adiabatic will fall down faster. So adiabatic will be below isothermal.
Okay.
Next one question. Okay, PV diagram, there are two ways A to C. One is from ABC and one is from straight A to C.
It will be adiabatic, isophobic. B2C adiabatic. It will be isophobic. For isophobic work done in the heat absorbed by the system in the process of AC, AB plus DC, del Q is equal to del U for AB process. For B2C is
You getting the idea?
we can individually find it, sir, and then
Okay,
add it
and
A to B and B to C.
dq equal to du plus pd both them. Okay, so if you know these two, then I can find dq, right? Okay, so du of A to C is same as du from A B C because u is state variable. It is not dependent on the path.
Yes, sir.
Okay, so to find du from A to C, I can go via this path, A to B and B to C. Okay, and PdV of AC I can find by this area. Okay, so both the things are known, from that I can find dq. Okay, that's how we have to do this problem. So we have to find dq, du of A to B and then B to C. So from that I can find du of A to C. So first to apply it to the path AB, take this process AB. So dq is how much?
For A to B, work done is 0. DU is 400.
That is equal to dp minus. Similarly for the process BC, du it's
F by 2 NR del T or del PV. Okay.
okay. So if we add these two, UV will cancel. Some background noise is there.
Sorry, what, sir?
Some background noise is there.
Yes, sir.
So from this, you know this one. So this is known. Okay, and PDV you have to find this area, and this PDV is 2 plus 6, that is 8. So what is the answer?
Sir, sir, I don't get it, sir.
Okay, this thing you got.
I don't even understand the question, sir.
No. There are two ways you can go from A to C, right? One is APC and one is straight A to C. Okay, so when you're going from A to C, what is the heat absorbed by that process? Okay, so for the process A to C, dQ to du plus PdV. So if I know PdV and du for A to C, I can know dQ for A to C. Okay, and for A to C, PdV is known, that is area under this one, this area. Okay, and du I can find by finding du of this process.
Yes.
Okay.
Yes, sir.
Using AB process, du equal to du has been given as 400. That is heat added. Okay, so that's plus 400 equal to du. PdV is 0. That is UV minus UA. Right? And then for process BC, du is 100 and it's also added. So it's plus 100. equal to UC minus EB plus PDV. PDV is this area. We have this rectangle. That area is this length, that is 6, 10 raised to 4, and this breadth, that is 2 into 10 raised to minus 3. Okay, so this thing is 120, and this thing is 500. If I add these two, B will cancel, UB will cancel, so I get UC minus UVA. This I use here. So from this I get UC minus UVA as 380. Right?
Yes, sir.
So that 380 will be in here, and PV is this area of this trapezium. The average of the parallel sides plus 2 plus 6, average is 4, into 10 raised to 4, and then distance between the two parallel sides is 2, into 10 raised to minus 3. So this thing is 80. This one. That is 460.
Yes, sir.
So the important thing is du is a state variable. So du of 2 points does not depend on the path taken by the points. So du of this C and A is independent of the path ABC or it's A to C. So I've used this process ABC to find du of C and A. Okay, so using that information, I can find dq of the process A to C.
Yes, sir.
Okay, this is trivial question. What the answer?
Is equal to 1 by 2 n of delta t. 1 5 by 2 n r is equal to P del V del PV. 2 minus
How to use ideal gas equation?
u equal to f by 2 nr del T.
What is the answer?
Wait, sir. I'm getting it as minus 15. B to M, A to B. Okay, A to B. I like to E minus 2 minus 15 J.
Okay. Yeah. CV is how much? Monatomic gas, right? CV of monatomic gas is how much?
What, sir?
5/2R.
Where it is diatomic.
Yeah, for diatomic is 5/2R, right?
CV. 7/2. 5/2, yes, sir. Okay, good. But if I use another formula, I'm not getting the answer, sir. Sir,
Yeah, so this is the which formula?
F/2 NR del T
What is the formula for?
for internal energy.
Then the formula is wrong. I don't know.
No, that's a standard formula.
This one.
Another formula F/2 NR del T, sir. In chemistry also we are studying that one.
Okay, then you have to check the formula. So because if you that formula will come out to be this one only. Because if you put in LA CV equal to 5/2R, then the formula should match. So
The formula is correct, sir. Standard formula, but I'm not getting the answer.
that formula should come out to be this one only. If you put this one.
Can you please explain why, sir? F/2. Okay, 5/4. All right. 1 into -3 -15. The del PV value for the previous diagram is -3 only, no, sir.
Which one?
Del PV value.
It's -8.
Okay. Okay, -20 kilojoule. Yes, sir. Got it. Maximum compressed. In an adiabatic process.
We have to solve this question.
We have done it now, sir. Compressed. We have seen now, sir, that graph.
Yes. Just a minute. This is the PV diagram. So compressing means this is the initial point. So adiabatic will go up steeply. This is isothermal. Okay. So the work done is maximum for adiabatic.
So what about isobaric process? That graph. Will
Isobaric
it be below isothermal or midway between adiabatic and isothermal?
will be less than adiabatic only. It will be somewhere here. No? Actually,
But
isothermal.
greater than isothermal.
No, isothermal will
Isobaric.
this is isothermal. Adiabatic. This is isobaric.
So it will be straight line, sir.
Isobaric is straight line only. This one isobaric is 0. Okay, so maximum will be A. Is it clear? The minimum is this one. Isoporic. Isoporic is 0. So maximum work done is for adiabatic. Next is isothermal. Next is isobaric. And for isoporic, the work done is 0.
For compression. For expansion, isothermal only will have more work now.
Yeah, expansion will be opposite.
But in all case, isobaric will have least work also.
Expansion means we is the starting point. So adiabatic will go down faster. Isothermal is like this. And isobaric will be like this. Straight. This is adiabatic, this is isothermal, this is isobaric. So expansion work done is maximum for isobaric, minimum for adiabatic.
Monoatomic gas and isotonically adiabatic final product of the gas. Mm, 1.6.
You can straight away use the formula, or you can do it as integral PdV.
We have two different slopes here also.
Yeah, for isotopic you have to use. What's the answer? I think I'm not doing. Okay, you just have to find the pressure at this point, P2.
They have final pressure at the volume 16.
Okay, so you know P1 V1 equal to P2 V2. From that I can find what about P1? Okay, so they have given us some P, right? Okay, let me have that as P only. P1 by V2 is half, right? So P2 is P by 2. But find this pressure, P3. So P2 V2 raised to the power gamma is P P3 into raised to the power gamma. And P2 is P by 2. And P2 by 3 is 1 by 8. It's a monoatomic gas. Gamma is 1.4, right? What is gamma for monoatomic gas? Is it 1.4?
1.66.
1.6.
They are given value, no, sir, 5 by 3.
Okay. This raised to the power 5 by 3. That is P by 2 into 1 by 2 raised to the power 5. Raised to the power 6.
So 1 minute, sir, I'll come in a minute. Sir,
Yeah.
can you please explain the previous one once again, sir? I don't get it.
Question 9 is clear.
No.
See, the thing is, it's going from state 1 to state 2, and then 2 to 3, and 1 to 2 is isothermal, 2 to 3 is adiabatic. Okay, so when you have isothermal process, this is valid. No, P1 V1 equal to P2 V2, because PV equal to nRT, P is constant. So P1 equal to P2 V2. P1 is P, and V1 by V2 is half. So P2 is known. P2 is P by 2, and process 2 to 3, PV raised to the power gamma is constant. So P2 V2 raised to the power gamma is P3 V3 raised to the power gamma. So from there I'll get P3 as P2, that is P by 2. Okay, and then V2 by V3, that is 1 by 16. Sorry, 2 by 16, that is 1
The
by 8.
1 minute, the 1 minute. V2 by V3. Okay. 2 by 16, 1 by 8, okay.
So P3 is P by 2 into V2 by V3, that is 2 by 16, that is 1 by 8 raised to the power 5 by 3. So 1 by raised to the power 5 by 3 is 1 by 2 raised to the power 5. So the answer is
Yes,
P2
sir.
raised to the power 6. That is
Yes,
64.
yes, sir.
So question number 20. This is a simple question.
Work done by the system in the cycle A, B, C, D. B, C, D, E, F, isomeric process Delhi Lima C to D. C to D. And D to E. Lima, Lima.
If these two areas are equal, so the sum will be 0.
So 1 minute, can you please explain it again?
The process is going from A to B, B to C, and then C to D, and then closing to A. So you have to find the work done in this process, right? So I can split it into two parts. So the work done from A to B, and then B to C. So that is work done from A, B, C. Okay. So work done from A to B is this area. Okay, and it's positive because volume is expanding. Okay, plus this area. Okay.
Work done from A to C only, no, sir.
No. You have to split it into two parts. That is same as work done from A to B plus B to C.
So I can.
Okay, this work done, and this work is negative because volume is decreasing. So sum of these two is area of this BCA, and it's a negative. So that's why I written here. So work done from A to B to and B to C is area of this part CPA, and you have to take the negative sign. Is that clear?
No.
Work done from A to B is this one, right?
A to B, yes, sir.
And it's a positive area.
Yes, sir.
Okay, and work done from B to C is this one. This area of this rectangle, and it's a negative area.
Yes, sir. Yes,
And you have to add these two. So it will become this area, and it's a negative area. Sorry, written here.
Okay.
Similarly, the second part, work done from C to B is this area, and it's a positive area. And work done from B to A is this area, and it's negative area. So the remaining thing is area of this one, and
Yes, sir.
it's a positive area. So
Yes,
I have
sir.
to add these two, and these two areas are same because it's half in the base and height, right? So
Yes, sir.
both the triangles, the base is same. Okay, and the height is also same. The area which is half in the base and height is same. Magnitude is same. So if I add, I'll get the answer as 0. Okay. So this was a trivial question. Okay, we can skip, right? A to B, B to C, and then C to A. So there is this enclosed area. What is the answer? What is the answer?
1 minute, sir. It is 6.5 years, sir.
It's half in the base and the height, right? Base is
No.
7 minus 2 is
C
5.
C points y coordinate is 6.5 years, sir.
Why 6?
C down x coordinate. Sorry.
7.
Okay. 7. Okay. 1000 plus. But they didn't include that area of the triangle, sir.
What's your answer?
1000 joule plus area of the triangle is L into B.
No, it's only the area of the triangle.
1100 joule.
You're not understanding the question then. You just have to find the area of the triangle. The work done from A to B is this area, right?
Yes, sir.
Okay, and it's a positive area. And work done from B to C is how much?
0.
Okay, and work done from C to A is this area. And that area is negative. If you add these two areas, the remaining area will be just this area of the triangle. And it's a positive
Yes,
area.
sir.
And it's a positive area.
Yes, sir.
What is the
Okay,
answer?
network done. 1000.
Okay, suppose I change the direction of the arrow. So this is worked into the cycle ABC, right? Suppose change the direction of the arrow, say CAB, then what will be the answer?
Like minus 1000 joule.
Yeah, because everything will reverse. So this is worked in for the process ABC, that is 1000. So take CAB, that the direction is reversed. So then area from worked in from B to A is this area. Okay, but this is negative area.
CAB, no, CB, yes, sir.
Yeah, whatever it is. Worked in from B to A is this green area, which is negative, and then worked in from B to C is this area, and it is positive. So if I add these two, I get negative area, which is minus 1000. Is it clear?
Yes, sir.
Okay, this is also trivial.
Length and bracket. So length is minus 2 PV, sir. Work done is minus 2 PV, but heat rejected by the gas means
Take this whole process and use a first of all dq plus du plus pdv, right? And what is du for the whole process?
0. It's a state function.
Yeah. So dq is same as dw. Okay. So dw is this area. So that area is this is 2b and this is p. So twice pv.
So minus 2 PV now, sir.
That we can fix later. So the magnitude is 2 pv. Dq equal to du plus pdv, right? So work done is this is first. This is A, B, C. This arrow is wrong. Okay. A to B, this is positive, so this is negative. Okay, but he has already included the sign in the statement. Okay. So
Okay.
this is asking the magnitude. So it's,
Yes, sir.
it's rejected heat one. It's minus P, 2 P only, but rejected means sign is included in the word rejected. Okay. Is it clear?
Yes, sir.
Okay, 23.
One mole of an ideal gas goes from an initial state A, okay, B to B.
So the clear question.
Why are two processes first undergoes isothermal expansion? Okay, expansion. From volume V to reduce to constant pressure isobaric. So what is the difference between A and D options, sir? First and last option, they look similar. Okay, direction change. Expansion, it will be expansion. D, sir, option D.
Constant pressure. So option this is out. Okay, and then isothermal expansion, right? So it's not straight line also. So
Fourth option.
option D. Okay, so B is out because this thing is not
Possible.
what is it?
Isobaric, so second one.
A constant pressure. Okay, so B is out, and then isothermal is not a straight line; it's a curve only. Okay, so this thing is out. So this thing arrow is wrong. Okay, okay. This one. So theoretical question.
Option B, sir.
Okay, this is very trivial. Right, 25th is the point. Okay, I think it's 2005, right? So it's we'll do this one. Efficiency of power engine depends on okay, this is also a theoretical question. You know the answer? You know the formula, you know the answer.
Minus Q2 by Q1. Temperature of the sea.
You know the formula for efficiency?
B, sir. 1 minus Q2 by Q1. Option B.
T2 by T1.
Or Q2 by Q1.
From that, how do you get the option B? Okay.
Q2. Q2 T2. We can use both, sir.
Only if you use this formula, you get the answer. Efficiency 1 minus
Yes,
T2.
sir. 1 minus Q2 by Q1 or 1 minus T2 by T1.
Okay, this was a trivial question.
Efficiency of an hydrogen. Freezing point. Okay. In Kelvin, how to convert on.
Is that ideal?
It's
Right. For ideal only this formula is valid.
T2 by T1 by the temperature of this thing. 373 by 373 is 100 by 373, sir.
Which option?
I'll use calculator.
Hey, Tori, என்ன பண்ற? பேப்பர் அடிச்சிக்கலாமா? பேப்பர் படுத்துக்காம.
%26%, sir. 26 point something.
Okay, option C. Okay, we'll close now.
Okay, sir.
Okay.